Hey y'all, this is Miss Grant going over equivalent expressions this morning, or whenever you choose to watch this video. This is our end game for today. We're going to make a foldable with our math properties and then some examples underneath it. Okay? So make sure before you start that you have your notebook open and that you have these two pink papers, because actually your foldable is going to be pink, not white. So make sure you got these two pink papers as well as your notebook in front of you. All right, let's get started. First off, when we talk about equivalent expressions, remember we're talking about expressions that look slightly different but have the same value in the end, or when we plug in the same value that we're getting the same answer. Okay, so today our objective is I can determine equivalent expressions using math properties or plugging in a value. This lesson mostly focuses on the math properties, but we are going to go over some examples where we do plug in a value. Okay. So the first thing we're going to do is make our pink foldable. Okay, so you should have one that says combining like terms on one side, the commutative property, and if you flip them over, they say identity property and equivalent expressions. Okay. When we make this, we want the combining like terms on the bottom. Okay. The next one we want is the commutative property. Okay, so then they're staggered like this. Okay, and this is going to be a lot easier for us. We take the top and we fold it over until all of our identities are seen, and the very top should say expressions with the same value done by. Okay. And then you fold. That's it. That's it. Easy peasy lemon squeezy. And we are going to staple this at the end. Okay. So let's fill out our beautiful flip book here. Okay. Equivalent expressions. They're expressions with the same value, and they're done by two different ways. The first one is to simplify with the properties. And the second way is to evaluate with a value. And you'll see evaluate a lot. It basically just means plug and chug, or plug it in and solve using order of operations. Okay, so today we're mostly going to focus on the properties, and our examples we're going to have both the simplify and evaluate. Okay. All right, we're going to look at our couple properties here. Our first property is the identity property. Okay, meaning we're not changing the identity of the number. So when we look at this, we're looking at just addition and multiplication. Well, what can I do in addition to a number so it doesn't change its value at all, or doesn't change its identity? Okay? And we know when we add a certain number to any number, we're not changing the value. And that number happens to be 0. Okay? So add 0 to any number, doesn't change value. Does not change value. And we can do an example. We can do 13 plus 0, and that's going to be 13. We're not changing what 13 is. We're not changing the value. Okay. With multiplication, okay, what can I multiply times any number, and the number is always the same? That's going to be 1. So any number times 1 is always itself. And we can do an example. We can do 7 times 1. It's still going to be 7. It's not going to change what 7 is. Okay. So when we think of the identity properties, we're not changing the identity of the number. We are not changing the number at all. Okay. Commutative property. Okay. Again, this is just for addition or multiplication. So the order for blank or blank does not change the answer. Okay. So I'm actually going to start with an example to kind of figure out our blanks here. Okay. Let's say I've got 7 plus 9. Okay. Let's say I've got 7 plus 9. 7 plus 9 is 16. Okay. If I change the order and I have 9 plus 7, what's my answer? It's still 16. So we know that the order for addition, okay, it doesn't matter about our order. Okay. Let's try another one. Let's try multiplication. Let's say 4 times 6. Well, I know 4 times 6 is 24. All right, well, what if I change the order of this? 6 times 4. 6 times 4 is still 24. So this holds true for multiplication and addition. Because it holds true for multiplication and addition, it unfortunately does not hold true for division or subtraction. It's not for addition, or not for division or subtraction. And we can do an example for that one up here. Okay. If I did 5 minus 10, okay, 5 minus 10 is actually negative 5. But if I flip this order, and I've got 10 minus 5, we actually get positive 5. So you get a totally different answer.
Ms. Gaffney, can you please call Ms. Harris at 1103? Ms. Gaffney, can you please call Ms. Harris at 1103?
Pardon the interruption. Okay. And for division, okay, you can do, again, same thing. You can do 5 divided by 10, and that's actually going to get you 1/2. But if I did 10 divided by 5, I actually get 2, so I get 2 different answers here. Okay, so that doesn't work. All right, if I wanted to make sure I had an example for variables, okay, let's say I have 5 plus w. So what can I do to this? So I'm using the commutative property. If I use the commutative property, all I'm doing is changing the order of it. So instead of 5 plus w, I want w plus 5. Same with this one. Let's say I've got 3b, or 3 times b. What could I do to show that I'm using the commutative property? I just changed the order. I now have b times 3. Same thing. All right, our combining like terms. Okay. Combining like terms you'll see more often. It is more frequently used than the other properties. Okay. Besides the distributive property, I think distributive property and combining like terms are your top 2 math properties that you're going to see. Okay. Like terms must have the same blank raised to the same blank. So we're talking about terms. Terms are separated by addition or subtraction. Okay? And because we're working with algebraic expressions, we now have variables. Okay? So like terms have to have the same variable, raised to the same, and we're saying raised to the same. When we say raised to the same, we're thinking of power. Okay, so we're thinking about exponents. We want it raised to the same power. Meaning I can't take an x squared and add it to an x. They don't have the same power. Okay. Terms take the blank symbol in front of it. Okay. Terms are again separated by addition or subtraction, and those are operation symbols. So terms take that operation symbol in front of it. This tells us whether or not we're going to add or subtract them together. All right, I've got 2 examples here. Okay. And what I suggest having is a different color pen or pencil with you so that it's, you can kind of separate your different terms. Okay. I've got y plus y plus y plus y plus x. Okay. I'm going to circle all my y's and the symbol in front of it. Okay. And then I'm going to box and use a different shape for my x's. Okay. How many y's do I have here? I have 1 y, because remember the coefficient in front of a variable is always 1. So I have 1 y plus 1 y, that's 2 y, plus another y, that's 3 y, plus another y, that's 4 y. So right now I have 4 y. I'm just combining them. And then I have this x last. Okay. So I'm going to take the operation sign in front, put it in front, and then put my term, x. My next one, I have 3x plus 2y minus x plus 7y. Okay, I'm going to circle all my x's, because that's the first one I see, and the sign in front of it. Okay. With the first term, you can assume that it's positive, even though there's no sign in front of it, we assume it's positive. Okay. I'm going to box in all my y's and the operation sign in front of it. I do want to rewrite this, so I put all my terms together. So right now I'm going to combine my circles. 3x minus x. And now I'm going to combine my squares. Plus, where am I getting the plus from? It is the operation sign with the 2y. 2y plus 7y. Now it looks a little cleaner. I put my x's together, my y's together. Now I can combine like terms. 3x minus 1x, because remember the coefficient in front of a variable is just 1. That's going to give me 2x. And then I've got 2y plus 7y. That's going to be 9y. I'm going to take the operation sign in front. Positive 9y. Okay. All right, let's try another one on here. So we're going to try 4x squared plus 2x plus 1y minus x. So I've got x squared plus 2y minus, or plus 1y minus x. So I've got a couple different terms here. Okay. So I've got the 4x squared. Remember, like terms must have the same variable raised to the same power. This has the x. Not only does it have the x, it has the power. Okay. So I'm going to circle the 4x squared. Do I see anything else that has an x? I have the 2x and the minus x. But they have to have the same power, so it is 2x to the second power. No, so they are not like terms. Is minus x to the second power. No, they are not like terms, so I have to leave them alone. Okay? I'm going to take my 2x, I'm going to box it in. I have a minus x. They are the same variable, and they are to the same power. They're raised to no power. Okay? And then lastly, I have my plus 1y. I'm going to use a beautiful triangle. We're going to use all the shapes here. All right, so I've got 4x squared. We're going to make this a little bit neater. We're going to take our boxes and put them together, plus 2x minus x. And then we're going to put our triangles together, plus 1y. This makes it a little bit easier combining them all. So I've got 4x squared. That's just going to stay where it is, 4x squared. We've got plus 2x minus x, and remember the coefficient is 1. So we really have 2x minus 1x, which is just plus x, or 1x. And then I've got my y's. I don't got to combine my y's, so I've got plus 1y. Not too bad. Okay, I'm going to leave that for the examples on that one. All right. We are going to staple these into our notebook. Okay. When you staple it into your notebook, make sure to staple it under your objective at the top. Okay. Right now, we are going to write some examples underneath. Okay. So you are going to write some examples underneath. Okay. Our first one. Okay. Use math properties to make an equivalent expression. Okay. I've got the first example, A, 2 times 3x plus 1 plus 7. And then I've got B, 9 times 2x plus 3 minus 4x. Okay. So make sure you have these written down in your notebook. Okay. All right. So first, I've got 2, and then I've got some parentheses. Okay. I cannot combine anything on the inside because I have the variable there. So which property do I want to use first? I want to use that distributive property. Even though we learned it before, we're going to use it here. So I want to use that distributive property to distribute the 2 to each term on the inside. Okay. So I've got 2 times 3x plus 2 times 1. Okay. And I'm just going to bring that as plus 7 along for the ride. So 2 times 3x is going to be 6x plus 2 times 1 is 2 plus 7. Now, we want to combine our like terms. Okay. Again, constants, remember constants are just the number itself with no variable attached. I want to combine these together, so I get the 9 plus, and I just bring down my 6x. So I've got 6x plus 9. That's a more simple expression. This is a lot easier to work with than our 2 times 3x plus 1 plus 7. Okay. All right, B, we've got 9 times 2x plus 3 minus 4x. Okay. Again, I can't combine anything on the inside because of that variable, and neither are like terms, so I'm going to use that distributive property to distribute that 9 to each term on the inside. Okay. 9 times 2x plus 9 times 3, and then bring that 4x, minus 4x along for the ride. So we've got 9 times 2x, which is 18x, plus 9 times 3, which is 27, minus 4x. Okay. Now we definitely want to combine our like terms here. I've got some x's. I've got the 18x. I'm going to circle it, and I've got my minus 4x, and I'm going to box in that plus 27. Okay. So we've got 8. Hello, marker. It'd be great if you worked. We've got the 18x minus 4x plus 27, and I've got the 18x minus 4x, and you're going to get that 14x plus 27. 14x plus 27 is a lot easier to work with than the 9 times 2x plus 3 minus 4x. Okay. Again, these are equivalent expressions, and all we did was use math properties to kind of simplify and make it a little bit smaller for us. Again, same equivalent expressions. All right, our next examples are more multiple choice. Okay. So it's going to take a minute for you to copy these down. Okay. We're going to use evaluation to determine equivalent expressions. So now we're done with the properties. Okay, we're going to evaluate now. We're going to plug and check. We're going to pick a number and plug it in and see if we can find an equivalent expression. Okay. So we've got 10 times 5x plus n. Here are our choices. This is what you would see in the FSA. You would see all these choices. And you can use the math properties to solve these, but today I do want to really practice this evaluation or to evaluate. Okay. So you got 10 times 5 plus n. Your choices are 5n plus 10n, 50n, 50 plus n, 50 plus 10n. And remember, when they are smushed together, letter and number, that just means multiplication, okay? That's one way to show multiplication. When you are evaluating, you are choosing the value for n, or whatever variable it is. You are choosing the value. Let me repeat. You are choosing the value. It is not given to you. You are picking it, okay? So you can pick whatever number you want. You can pick 100, you can pick 5, you can pick 10. My recommendation is to use an easy, low number, okay? So let's gonna pick n equals 1, okay? 1 is easy. You pick the number. It is easy to work with 1. You can plug it in. It's easy to multiply with. You don't have to pick anything crazy or big. That's why I always recommend picking a low number, okay? So now, we're gonna plug in this n for each of these and see if we can get an equivalent ratio. Or not ratio, expression, okay? So let's first start with our actual problem, 10 times 5 plus n. Let's plug 10, 5, plus, and instead of n, I'm going to put 1 there, okay? So we actually have, this is the same as 10 times 5 plus 1 is 6, which is going to be 60. So we want one of these to be 60. Okay, if it is not 60, it is not an option. Okay, so we've got 5n plus 10n. So first off, we have 5 times, and instead of n, we're going to put 1, okay, plus 10 times, instead of n, we're going to put 1, okay. This is the same as 5 times 1 is 5, plus 10 times 1 is 10. That's 15. That is not an option. Next one, we have 50 times, instead of n, we're going to put 1. And 50 times 1 is going to be 50. Remember, this is our identity property of multiplication. 50 is not 60, not an option. 50 plus, what are we going to plug in for n? 1. 50 plus 1 is 51. 51 is not 60, not an option. So you'd like to think, oh, Miss Grant, D hasn't been picked yet. D's got to be it, so I'm just going to circle D. Okay, you want to make sure that that's actually the correct answer. Okay, so we have 50 plus 10 times, instead of n, we're going to put 1. So we have 50 plus 10 times 1 is 10. 50 plus 10 is 60. Woohoo! 60 wins, so yes, it is D. Okay. Yes, we could have used process of elimination. You could have also used math properties to distribute the 10, and you still would have got 50 plus 10n. But this is just with evaluation. So if you are not comfortable with the math properties, but you are comfortable with evaluating, use evaluation. Okay. All right, last one. We've got 24m plus 12. Oh my gosh, this is so much work. Okay, we just take it one step at a time here. Okay. We've got our options, 9m plus 6 plus 9m plus 6. 2 times 6m plus 3 plus 2 times 6m plus 3. 35m plus 5 minus 11m plus 7. Whoa. 12 times 2m plus 1. Whew, that is a lot, and that is a mouthful. Okay. We just take it one step at a time. Okay. All right, let's pick a value for m in this case. Okay. I suggest picking a low number. Okay. Let's go with m equals 1. Boom. Okay. If this video cuts off at my 20-minute mark, pause here and finish the problem on your own. Okay? So pause here and finish the problem on your own. Again, if the video cuts off, pause here, finish the problem on your own. Okay? All right. So again, first off, we have to figure out what our answer actually is going to be. So we have 24 times, instead of m, we're going to put 1 plus 12. So we've got 24 times 1, which is 24, plus 12. 24 plus 12 is 36. So we want 36 as our answer. All right. We got 9 times, instead of m, we're going to put 1 plus 6 plus 9 times 1 plus 6. All right. This isn't going to be too bad. 9 times 1 is 9. Cool. 9 plus 6 is 15. Awesome. Plus 9 times 1. 9 times 1 is 9. 15 plus 9 is 24. Okay, we're doing good. 24 plus 6 is going to be 30. That is not an option. Okay. All right, next one. We've got 2 times 6 times 1, because we can't put m, plus 3, plus 2 times 6 times 1, plus 3. Notice how these are just duplicates of each other. This is going to make it a lot easier for us. Okay? So we have 6 times 1, which is 6, plus 3, which is 9. 2 times 9, which is 18. Okay? So we have 18. Plus, if I know this is 18, this is the same thing, that's going to be 18. 18 plus 18 is 36. You're like, Miss Grant, I'm done. It's the answer. Okay, maybe not. There might be more than one option. Okay, but we're going to circle B. Okay? All right, I need to erase it. All right, we have 35 times 1 plus 5 minus 11 times 1 plus 7. All right, this is a doozy. We got 35 times 1, that's 35, plus 5, that's 40. Okay, so we got 40. Minus 11 times 1, which is 11, plus 7. So 40 minus 11 is going to be 29, plus 7. That's going to also be 36. Oh my gosh, that's also an option. If somehow my math is wrong here, just let me know. Okay. All right. Doing good so far. Yeah, we're doing good. We're doing good. 36. Cool. Last one. I have erases. All right. We've got 12 times 2 times 1, because we're not putting them anymore, plus 1. So we have 2 times 1, which is 2, plus 1, which is 3. So we have 12 times 3, which is going to be 36. Oh my gosh, we have 3 as an option. Okay, this was most likely one of those problems where you select all that apply. Okay, so you'd have 3 options here. Yay! Okay, so again, if you are not comfortable with the math properties, evaluation is the way to go. A little bit messier, a little bit longer, but if you are not comfortable with the math properties, you have another option to determine an equivalent expression. Okay. If you have any questions, feel free to ask your math teacher, meaning myself. Look up resources online, meaning YouTube. Okay. All right, guys. Again, make sure you staple this into your notebook. It should cover all of your examples, or most of them anyways. Okay. So this is your end game. All right, guys. Have a fabulous day.